scientific notation. Again, I know I already said it. It is basically like we're filling in two blanks. Something times 10 to the something power. It's always times 10. Because it's essentially asking you how many times would you have to move the decimal to get this big old number we have here. So the decimal right now, this is 56,900,000. The decimal is technically right there, and there are infinite zeros behind it. But we need our number to be between 1 and 10. So where could I place the decimal in this to make it between 1 and 10? It would be right here. So it would become 5.69. Now, the exponent would be how many places would the decimal have to move from where it is to where it needs to be. Now this is a very large number, which means our exponent will be positive. So we will say it is 5.69. Let's see, to 1, 2, 3, 4, 5, 6, 7. To the 7th place, or to the 7th power. So you count from where it needs to be to where it is, and that's your exponent. Easy peasy, squeezy lemons, yeah? All right, so this one, our decimal would have to be here to make it 9.85. Now this is a very small decimal, which means our exponent will be negative. So we count from where it's at, or from where it needs to be to where it's at. So look, 1, 2, 3 places. And also another way you can do it with these very tiny numbers is just count the zeros in front of the first digit. There's 1, 2, 3 zeros, right? 1's in front of the decimal, 2 aren't. 3 zeros in front, so it's to the negative third power. Write each number in scientific notation. 267,000. It would have to be 2.67 times 10 to the, it's a very large number. So let's see, 1, 2, 3, 4, 5. 10 to the 5th. B is also a very large number, 46,205,000. So the decimal would have to go after the 4. 4.6205. Now, a lot of times when you see numbers represented in scientific notation, they don't go past the second decimal spot, the 100th spot. But it's fine if you do. This is a little more precise. So let's see. 1, 2, 3, 4, 5, 6, 7 places times 10 to the 7th power. Now look at this one. You serious right now? Look how small that number is. So I know that's going to be a negative exponent. I know the decimal's going to have to go there. 3.25. Now, you can count the decimal spots or just count the zeros in front of it. 1, 2, 3, 4, 5. 10 to the negative 5th. Easy as pie. Or you could say, oh, well, let's move it. 1, 2, 3, 4, 5 places. Cool. And then here we have another very small number. We need the decimal here after the 9, 9.0, which we could just write as 9. Very small number, negative exponent. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So times 10 to the negative 9th. Or count how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, however you're going to get that answer. So now we've written them into scientific notation. The next slide, we're going to try writing them in standard notation. So they'll give us the scientific notation, and we're going to have to write out the very large or the very small number.